let's have a look at this question. It's number 3 on the week 1 work. And it begins, a landscape architect has included a rectangular flower bed measuring 9 feet by 5 feet in her plans for a new building. She wants to use 2 colors of flowers in the bed, one in the center and the other for a border of the same width on all 4 sides. If she can afford just enough plants to cover 24 square feet for the border, how wide can this border be? Okay, so the first thing that I would do in solving a question like this is to draw a diagram. We've got to understand what we're looking at here. So we have a flower bed and it is rectangular, which means that 2 sides could be a different length than the other. A square is a particular kind of rectangle where all 4 sides are the same. So we have this rectangular flower bed where we have 9 feet on one side and 5 feet on the other. So within this rectangular flower bed, there's going to be a border. So a border means that there's something all the way around. Now my diagram isn't very exact, so you'll have to forgive me here, but imagine then that we've got this inside rectangle and a little border around it. So the first thing we might say is, well, let's let X represent this border. So we're going to have X and X here, right? That's going to represent that width, and X, it's the same width all the way around, and X here, right? It's the same width all the way around. Now I've written just trying to make that dimension there. It's not a negative sign, it's just a dimension. Okay, so we know that this outer area, the area of the big rectangle, so we have outside area, so we're going to have outer area, and that equals length times width, and the outer area's length is 9 and the outer area's width is 5, so that's 45 square feet being the units of area. And we are told in the question that the border is 24 square feet. So border area. So that's just this bit, right? And if we're looking then for the area of what's inside, you can imagine it's going to be the difference then between the outer area and the border area. So we have the inner area is going to equal, let's write this 24 square feet. So the inner area is going to be 45 square feet minus 24 square feet, right? And that's going to be 21 square feet. So that's that inner area. So now we have the areas of the whole rectangle, we have the area of the border, and we have the area of the inner rectangle. And so if we're going to be able to find the dimension of the border, we're going to need to find that value of X. So let's have a look at this. When we have 9 feet here, and we're going in X on both sides, we might say that the length of the inner area is going to be 9 minus 2x, right? And if we look here at the length of this side of the rectangle, we've got 5 feet, but again we're going in an X on both sides of the inner area, so that width of that rectangle inside is going to be 5 minus 2x. And again, you're going to remember that length times width is the area, and that these are the dimensions of the inner rectangle. So we can multiply those together and find the area of that inner rectangle. And we know that the area of that inner rectangle, we found that as 21 square feet. So now we can say that 21 square feet is equal to 9 minus 2x times 5 minus 2x. So we can just expand those brackets and solve for x. And I think seeing here x times x, we're going to have a quadratic. So we're going to be either factoring or using the quadratic formula. I'll continue this on a clean slide so we have a lot of space to work. The first thing we have to do here is expand the brackets, and there's a couple of methods people have probably used or been taught. But you have to recall either method you use. We've got to multiply each of the terms in the bracket by each of the other terms in the bracket. One method that is probably not very common, but I find kind of useful, is to put your terms like this in a little grid. And then it lets you remember that you need 4 terms at the end, and you're just multiplying 9 times 5 is 45, and here minus 2x times 10 is minus 10x. Here we have 9 times minus 2x, which is minus 18x, and here minus 2x times minus 2x is 4x squared. And that way now I can gather up the like terms, and I've got a full expansion of those brackets. So let's do that. 4x squared, and now we've got minus 18x and minus 10x, so that's minus 28x, and we have a plus 45. Now you can see, as I suggested on the last slide, that we're going to have a quadratic. We have an x squared term, so now we need to move the 21 over to the other side so that we've got 0 on one side of this quadratic. So we still have 4x squared, we still have minus 28x, and here we have 45 minus 21, so we have plus 24 here. Okay, so now we want to solve for x, and we know there are 2 ways of doing it. We can either factor, or we can use the quadratic formula. And I would suggest, if you're not strong on factoring, well, you can always use the quadratic formula. It works every time. But I'm going to take you through the factoring exercise because this one is fairly straightforward. I might look at this and say, well, gee, I seem to have a common factor of 4. Each of the coefficients in each of the terms is divisible by 4. So maybe I should subtract that out, or subtract negative 4. Okay, so 0 equals 4 times x squared minus 7x plus 6. So I'm reminded that in order to factor this quadratic, I'm looking for 2 numbers that add to minus 7, and the same 2 numbers need to multiply to minus 6. So I'm looking at minus 6 and minus 1. So minus 6 and x minus 1. Okay, and again I'm setting it equal to 0 and solving, so this is obviously not going to be the correct answer. X minus 6 equals 0. So x is 6 in this case, or 0 equals x minus 1, where x is equal to 1. So those are the 2 possibilities. Either the border is 1 foot wide or 6 feet wide. And so now we actually just have to look at the question and say, well, which one makes sense? So we know that the width of the outside rectangle is only 5 feet. So clearly the border can't be wider than the one side of the rectangle. So that would lead us to understand that the border has to be 1 foot across on all sides. You should go back and check to make sure that this makes sense within the question, where the inner rectangle has sides of 9 minus 2x, so 9 minus 2x, and the width has 5, sides 5 minus 2x. So basically one side is 7 feet and the other side is 3 feet. And if we multiply them together to get the area, we're arriving at an area of 21 square feet of the inner rectangle, and that would be correct.